Good morning to all. Today we are going to discuss about the Cauchy's theorem, Cauchy's integral formula, generalization of Cauchy's integral formula. So using Cauchy's theorem, Cauchy's integral formula, we can evaluate the integral value without converting into the single variable. If you observe the line integral, in that case, some function is given, we are converting into the single variable using the given equation or points or parametric equations. But without using this type of the procedure, using the statement of Cauchy's theorem or Cauchy's integral formula, we can evaluate the line integral value. Cauchy's theorem, this is also called a Cauchy's integral theorem. If f of z is an analytic function and f dash z is continuous within and on a simple closed curve C, then integral of f of z dz equal to 0 over C. One function is taken, f of z is a function, it is analytic function. F dash z is continuous within and on a closed curve C. Take one curve C, that is simply closed curve C. That means it doesn't cross itself. Take that curve. In that curve, the given function is analytic. If you consider the one curve, inside the curve, the function is analytic. Then integral of f of z dz is 0. Okay, that means any function, if you take or we want to evaluate the integral value, the given function is analytic in the given region, then you can apply the Cauchy's theorem. By that theorem, directly we can write integral value is 0. Cauchy's integral formula. If f of z is analytic within and on a simple closed curve and a is any point within C, then f of a equal to 1 by 2 pi integral f of z by z minus a dz. So here function is given, that is analytic function within and on a simple closed curve C and a is any point within C. That means take one curve, inside the curve take the point, that point is A lies inside C. The given function is analytic within the curve and A is any point within C. Then the line integral f of a equal to 1 by 2 pi integral f of z by z minus a dz. That means if you observe this statement, in this case, this function fails analytic at z equal to a, and that point also inside the C only. That means the given function is not analytic at some point and that point lies inside the region. We need to use the Cauchy's integral formula. Observe the difference between Cauchy's and integral formula. First observe where the function fails to analytic. Next check that point inside the region or outside the region. If that point outside the region, use Cauchy's theorem. If the point inside the region, use Cauchy's integral formula. By that formula, we can write f of a equal to 1 by 2 pi integral f of z by z minus a dz. Generalization of Cauchy's integral formula. If the same statement is exist, we are extending this value to different powers. Here we have z minus a exist. Z minus a whole square, whole cube, whole power n plus 1. Then we get the corresponding value. If f of z is analytic within and on a simple closed curve C and a is any point within C, then f power n of a, that means nth derivative of f at a equal to n factorial by 2 pi I f of z by z minus a whole power n plus 1 dz. So this is extension of Cauchy's integral formula only. Based on the denominator part, we use either Cauchy's integral formula or generalization formula. Let us look at the problem. Evaluate integral z square plus 4 by z minus 3 dz where C is defined two regions. First one, modulus z equal to 5. Second one, z equal to 2. Taken in anti-clockwise sense. Always anti-clockwise direction is the positive direction. We are taking clockwise is the negative direction. So we want to evaluate this integral value. Here two regions, two different regions are given. Along the two regions, we need to calculate the integral value. First take this function as pi. Pi of z equal to z square plus 4 by z minus 3. Now check where this function fails to analytic. If you take the denominator is 0, z minus 3 equal to 0, z equal to 3. Z equal to 3 case, the function is not analytic. Remaining all cases, the function is analytic. So pi of z is analytic everywhere except z equal to 3 case. So this point is called a singular point. Z equal to 3 is a singular point. So take the first region, modulus Z equal to 5. So we have to check this point lies inside the region or outside the region. What is the meaning of modulus Z equal to 5? Modulus Z equal to 5 is a circle with center 0 and radius 5. So that we are taking the one circle with center 0, radius 5. From the center to any side, distance is 5 only. So Z equal to 3 lies inside the region directly. We can do anything. Directly you can say Z equal to 3 lies inside the region. So that means what? This point is the singular point. This point inside the region. If the point lies inside the region, we need to use the Cauchy's integral formula. By the Cauchy's integral formula, we can write 1 by 2 pi integral f of z by z minus a dz. So integral f of z, z minus a dz equal to 2 pi I into f of a. Take the given functional value 2 pi I into f of a. A is z minus a, z minus 3. Comparing a is 3. So f of 3. So where f of z equal to, f of z is what? Comparing numerator values z square plus 4. We need to find f of 3. Substituting z equal to 3. 9 plus 4, 13. So into 13, that is 26 pi I. Next, second region, modulus z equal to 2. Modulus z equal to means it is a circle with center 0, 0, radius 2. So draw one circle, center 0, radius 2. That means endpoints. What are the endpoints? Here 2, minus 2, upper part 2, lower part minus 2. Our point is what? Z equal to 3. Z equal to 3 lies outside the region only. So if the point lies outside the region, we use Cauchy's theorem. By the Cauchy's theorem, integral value is 0. So this integral is 0. Next, evaluate integral e power z by z plus 1 whole square dz around c z minus 1 equal to 3. So evaluate this integral value along the curve z minus 1 equal to 3. Take this function f of z, pi of z equal to e power z by z plus 1 whole square. First check where this function fails to analytic. Denominator is 0. Z plus 1 whole square equal to 0. Z equal to minus 1. So the given function fails analytic at the point z equal to minus 1. That means remaining all cases it is analytic. Pi of z is analytic everywhere except z equal to minus 1. So z equal to minus 1 is a singular point. So take the given region z minus 1 equal to 3. What is the meaning of this one? Z minus 1 equal to 3 means it is a circle center at z equal to 1 and radius 3. So taking the center as 1 and radius as 3, draw the circle. Radius 3 means what? From the center all the sides 3 units. Okay, so all sides are 3 units we are taking. Now check the point z equal to minus 1 lies inside the region or outside the region. This is 1. From right side 3 units, left side 3 units. So here 1, 2, 3. So last endpoint is 4. Here 1 to 0, 0 to minus 1, minus 1 to minus 2. So minus 1 is also inside the region. So the point lies inside the region. Inside the region case, we use the Cauchy's integral formula. Observe the term here, z plus 1 whole square exists. Only whole power 1 exists, we use Cauchy's integral formula. But for more than 1 exists, we use generalization formula. So this is unequal to 1 case. That is e power z by z plus 1 whole square dz equal to 2 pi I into f dash a. So 2 pi I into f dash a. What is f value? F is e power z. F dash is differentiating. E power z differentiation is e power z. Substituting the point a. A is what here? Minus 1. Okay, substituting f of minus 1 is e power minus 1. Substituting 2 pi I into e power minus 1. 2 pi by e. So integral of e power z by z plus 1 whole square dz equal to 2 pi by e. So any point which lies inside the region, if the singular point lies inside the region, use Cauchy's integral formula. The point lies outside the region, use Cauchy's theorem.